I think we can get started. If anybody is still coming, then that's fine. So I am just going to go ahead and start with today's Tech Talk. Welcome, everybody. It's great to have you here. We are doing our 27th Tech Talk, which is exciting. We're very happy to see that. Everyone is participating like that, and it's just very nice to see that we can keep this format going. My name is Helena, for everybody who doesn't know me yet. I am here today instead of Ariane, who usually moderates our Tech Talks, but she's out of office today. So I will be here guiding you through this talk. And yeah, welcome. As I said, my name is Helena. I work for ALASCA. I've been employed by ALASCA now for the past 5 months. Time flies. And I work in our ALASCA Focus project specifically. And I am responsible for everything communication and documentation for ALASCA in general, but also specifically our ALASCA Focus project, which is the funded project that we have. Please note that the session will be recorded since we'll be uploading this on YouTube later on. I think you all had to click a little thingy when you came in, but just so that you are all aware of that. I'm going to hop right into today's agenda. We are going to start a Tech Talk very soon, and then there will be plenty of time for discussion. So if you have any questions, please remember them, and then we can talk about them later on after the Tech Talk has finished, or you can also put them in the chat function, and then you can also collect them there. After our Tech Talk, I will be giving you a little bit of an overview over our news and events, and then of course we have the save the date for the next Tech Talk. Welcome to our 27th Tech Talk, Stefan Meyer, CTO at Excellent Technologies, who will be presenting the topic On-Prem Kubernetes at Scale with MetalStack.io. Yeah, without further ado, I will be stopping my screen share and then giving the microphone over to Stefan.
Thanks, Helena, for the introduction. I will try to share my talk now. Okay, can you see my screen?
Yes.
Okay. So, as Helena already said, my name is Stefan Meyer. I'm CTO at Excellent Technologies GmbH. We are a small company from Munich, and I give you a talk about MetalStack.io, which is our open source project regarding on-prem bare metal Kubernetes. Let's dive into. We are already as a company working in Munich, from Munich since 1999. We're celebrating today actually our 25th anniversary. We're very proud of that we made it this far. We are 35 employees, mainly working in the finance and insurance sector, nowadays also in the power distribution sector. Based on our open source project, we are also a hosting provider for Kubernetes as a service, found at MetalStack.cloud, but I will focus on our open source project today. We are member of the CNCF, silver member. We are obviously ALASCA member and also part of the Neo-Nephos Foundation. This is basically what we are, what I am, and most of the time I held this presentation together with my colleague, Garrity is not here today, but joining the talk. So if we have questions later on, we both are able to answer all questions you will have. Yeah, the change in the world we all see is probably a good boost for European clouds. Yeah, So the movement towards autocracy in the US and the rise of companies, for example, Broadcom, which enhance the pressure to their customers to rise the license fees and so on, is, in our opinion, ring bell for all of us to move away, if possible, from the US-based hypervisors towards European-based clouds. But are there any purely European cloud technologies available? We think yes. And one of the possibilities is our MetalStack.io open source project, which is able to provide the same feeling or level of API-based cluster and cloud provisioning as you are used to get from AWS or Google. And how that works, I will try to show you in this slide deck. What is MetalStack.io? It's a set of microservices that implements Metal as a service. So it is responsible to automate the full hardware stack in your data center from the very bottom to provide Kubernetes as a service to turn your hardware into an elastic cloud infrastructure. It not only takes care of the provisioning of servers, it also automates the provisioning of the whole network stack. And with that, we are able to create services on Kubernetes, based on Kubernetes and Kubernetes itself in a matter of minutes, fully API based. And on the right side, you can see a simple use case. So end user will ask our API to create in a specific location, specific set of hardware with a dedicated operating system and a network connectivity. And the Metal API takes care of the rest. So it looks for free machines with a specific resource request and creates the network. And 2 minutes later, the machines and the network is ready to go. Why should we use bare metal for Kubernetes or bare metal at all and not rely on virtualization technologies? Because we think nowadays with bare metal machines you get the best performance. Virtualization is fast, but especially in I/O intense workloads, it's far behind the raw performance you will get on a bare metal machine. Especially if latency is important, which is always the case for databases or AI applications. You also will get the highest level of possible tenant separation. So not the hypervisor will separate different customers from each other. The physical hardware will separate them. So this is there's nothing more possible than doing that on the hardware level. You do not have the influence of other noisy neighbors which might influence your workloads. Also, you will get a simpler stack. So the hypervisor itself is a very complex software which needs to understood, and taking that out of the game, you will have a much cleaner stack. So your workload directly runs on the CPU, nothing in between. And it's optimized for the modern AI workloads. For GPUs can be fully utilized in a bare metal machine. You can also run virtualization on top of Kubernetes if you have some legacy applications which are not ready for the containerized world. There are obviously some cons. So if the hardware fails, it fails. You cannot over provision hardware, and there is no live migration. But all of these downsides are, in our opinion, mitigated by the use of Kubernetes as an orchestration framework. And what is Metalstack actually doing? What is it responsible for? So it manages, as I said earlier, the whole stack inside your data center. So beginning from the rack, the machines, the network, firewalls, operating systems, and even higher level network network objects like load balancers and so on. It's fast, slim, and scalable. You do not have any vendor lock because it's all open source. You can run it on premise. You do not have any dependencies to other cloud providers because it's running inside your own data center. And with that, you gain complete data sovereignty. So everyone can use it in his own data center. No license fees are required in principle. And with that, you get a very great price to performance ratio. The bigger the setup gets. So as more requirements you have, the more cost-effective this approach will be. And if you run this kind of cloud inside your own data center, Kubernetes there, you will get very low latency connections to your existing legacy company internal networks because it's directly connected. You do not have to spin up very expensive and latency network connections to from the cloud provider because it's running inside. And it's all API driven and implemented in modern in Go, like Kubernetes itself. And we use that in production since 2018. It started for a financial data center provider in Munich, very critical industries. And what we currently use is know about the production setups. It's roughly these numbers. So several 100,000 containers are running on top of the infrastructure we manage with that. More than 250 Kubernetes clusters, a lot of switches, a lot of servers, and a lot of persistent storage. So it's not a small implementation. It's battle-proofed in production usage. No, don't be afraid. I'm not going to details very deep. This is an overview picture of how Metalstack works. Basically, it's divided into 3 parts. So there's a control plane, the blue box on top, the so-called metal control plane, which runs typically on Kubernetes itself, where the API resides, and the stateful sets where IP addresses, for example, and machine data are stored. Then the red box below is the actual stuff which resides inside the data center. So the servers, the switches, and some management infrastructure, basically a server or 2 servers which host some services, microservices, which are responsible for booting them and turning power on and off. And obviously the last part on the left side is the API access, either through a command line tool or through libraries, or even with SSH to access the console, so the serial console of the servers. So this is the low-level, so-called low-level access, which is basically used for the administrators, but most of the time used by a higher level API, which I go into later. So the design of it is driven by the scale by rack design. So we don't care so much about the individual server. We have a blueprint how the rack should be designed with a clause topology, where the BGP is the heart of the network to create a fully redundant data plane. And all servers are dually attached to two switches on top of the rack. We have fully documented what we are support currently at docs metalstack.io, and we also did a lot of ugly work to abstract away the differences between different hardware vendors in a dedicated library, because IPMI, Redfish, and so it is not so fun. We actually rely mostly on Open Compute hardware. On the switch side, we use Open Compute compatible switches with the Sonic operating system running there. And for on switches with port speeds from 1G to 800G, and a small controller is running inside these switches on the Sonic operating system, which reconciles the changes enforced by the API and reconfigures the switch every 10 seconds or so. On the server side, we actually support Supermicro, some OCP hardware, and Dell servers. We require 2 NICs connected to the switches, Pixie, UEFI. We also support a local NVMe drive and have special images built by us based on Debian and Ubuntu. Because we always use BGP to the host, we use FRR routing for that to get these fully redundant data plane setup. Here's an overview of how our networking works in principle. So starting from below, we have a network. The green box on the left side represents the hardware setup which is required for one single Kubernetes cluster, some nodes, and a firewall. These nodes are connected to VRF, so virtual routing and forwarding instance on the switch of the data layer, this VRF is connected to the firewall, and the firewall is also connected to external networks. Here in this example to the internet VRF. On the right side, there's a second Kubernetes cluster which also has a connection to a data center interconnection, for example, your internal legacy network. These VRFs are spread across the data plane with VXLAN EVPN, and then the connectivity from the outside to the nodes and vice versa is possible and controlled by the firewall, which is also a dedicated physical machine, and the firewall rules there are automatically generated out of Kubernetes resources. And to draw the bigger picture, so we were talking now up to now until the MetalStack layer. So MetalStack is responsible to manage the switches, the servers, the operating system, and the operating system on the switches based on the API. And at the end, we want to create Kubernetes cluster, and therefore we use the Gardener open source project, gardener.cloud, which is originally founded by SAP and also part of the NeoNephos Foundation. And with that, we can create Kubernetes clusters. All of these software is, so Gardener and MetalStack is developed in Europe or Germany in specific. And with this whole stack, you can create at the end containers, obviously, on premise. You can create VMs or GPU workloads. So what is this Gardener? Gardener is, as I said, the open source project by SAP. they use it for their own SAP cloud. Website is gardener.cloud.
Stefan, I think you muted without willing to do it.
Yes, you accidentally muted yourself. Just a couple seconds though. Stefan, can you hear me? Stefan? Stefan?
Someone.
There you are. All good.
Someone muted me.
Yeah, just I think the past minute. If you could just go back a couple points. Sorry about that.
This one?
Oh no, not that far, not that far.
Okay, so the question is, how can we create Kubernetes clusters? And we use the Gardener project, which is an open source project founded by SAP back in 2018. Gardener.cloud is the website. It's open source, Apache licensed. It's a cluster manager, Kubernetes installer, cluster orchestrator. Founded basically at the same time as we started with MetalStack, and we are in a tight cooperation with the Gardener project since then. We also organize half-year hackathons together, and Gardener itself is used inside SAP to manage thousands of Kubernetes clusters on 100,000 of machines, and it is used to create Kubernetes cluster also in a reconciliation loop and separates the control plane from the worker node, so the end user will not be able to manipulate the pods on the control plane like the etcd or the API server. And this makes it a perfect fit to build Kubernetes as a service, which scales very well. You do not need a lot of ops people to even manage thousands of Kubernetes clusters. Yeah, so up to here is the MetalStack IO project, including Gardener. And we offer this whole setup as a pre-configured rack. We have a small rack, which is on wheels. We call it starter with 8 servers, half rack. And we also, for people who want to try that technology in their own buildings, for example, and we can from there on define how a bigger setup would look like depending on the customer demands. Looks like that. So this is the smallest possible configuration in our point of view to run MetalStack and Gardener to create Kubernetes clusters on bare metal. We also offer, based on that technology, MetalStack Cloud. It's a self-service cloud running, deployed here in Munich in a data center, and the whole environment is owned by us. You can try it out and order Kubernetes clusters. They are built by the minute. It's perfect for if you like to have quite high performance Kubernetes clusters for databases or other data intense workloads, which is made and hosted in Germany and therefore fully DSGVO or GDPR compliant. And it's based on the same technology we have here presented, and the development of MetalStack IO is done by the people in our company. About 10 to 15 people are involved on a regular basis. We release on a 2-week release cycle approximately, and the upcoming topics we are actually working on is complete the IPv6 support. We have dual stack Kubernetes clusters available. We also try to achieve the offline environment deployment. So for people who would like to get a complete isolated environment without internet connectivity and still want to have this cloud feeling, this is a bit of a challenge. Then resource scoping, so V2 APIs in the making, and all the time broader hardware support. You can try it out. We have a full virtual setup. You can clone the mini lab, we call it, and run it on your laptop, and you will get a full Metal Stack IO environment running on your laptop. This is perfect for doing development. At least I want to point out our documentation, our GitHub org, the Slack channel, and the pointer to our continuous release cycles and released versions of Metal Stack. So that's so far. If there are any questions, I'm welcome to answer them or try to answer them. I see that Garrett already answered a lot of the questions.
Yeah, I'm sorry. But there were many of them, and I think they were good. So
yeah,
we can
nice.
iterate through them again. So
so don't be shy. You also can ask them here publicly.
yeah, one question was about the smallest setup, I think, that we had. I referenced that we have the small portable setup in the rack format.
Yeah, this is the smallest
quite
setup.
new. Yeah.
In our opinion.
So it has 8 nodes, right?
It's 8 nodes, 1G networking, but it's easily possible to have 25G networking. You will not end up having more space or requiring more space, but a bit more power. Yeah, it's 8 nodes, and every node can have in this setup between 4 and 16 cores, and between 16 and 192 gigs of RAM, and 2 NVMe drives. So these small machines, you might see here, these are is a 3U unit with 8 so-called almost blades, and very small ones, but still quite capable. Any further questions?
How much invest is the starter rack? Roughly.
The starter rack we rent it. It's about, depends. I guess it's about between 3 and 5K per month, and it's not meant for production usage. So you can rent it for maybe 3 months and then decide, okay, that's the technology I want, and then we will design for you a blueprint with a production ready setup.
Could you elaborate a little bit on your bare metal provisioning setup? Because we had this the last time the Uhuru guys talked a little bit about that as well. Because this is always a little bit the problem, I think, for bare metal setups. Because
Yeah.
in the virtual world, it's easy to provide a new node. Is this on what is this based? So can you talk a little bit about that?
So it's basically the machine need to be set up to boot from Pixie, which is the default. If you order new machines, it's usually the default from all vendors. So you just power it on, and with Pixie, it will then get a special initial RAM disk and kernel built from us. It's called Metal Hammer. You can see it on our GitHub repo. It boots up. It's very small, 40 megabytes. It boots up, and does inventory steps. So it checks how big the machine is, how it is connected to the network, and if this is all fine, it will register it against our API, and from there the API knows about that machine. It's this size, maybe C1 large, or depending on CPU, memory, and disk. Has this specific size, and then this initial boot disk or this metal hammer will stay there and waiting for an allocation request. So if afterwards someone asks for a C1 large machine, the metal API picks one of the waiting ones, and immediately one of these machines will download the operating system image the user requested and burns it to the disk, and kexec after that into the newly installed operating system. With that, we can bring a machine up in about 1 minute. So when you order it via the API, 1 minute later it's there and ready connected to the network you ordered. It's quite reliable and fast. If you use the Kubernetes clusters based on MetalStack and Gardener, you will not notice any difference to what you get from Google Cloud, for example. So node roll or autoscaling is about the same speed as you will get from Google GKE, for example. And the newly created cluster is ready in about 6 minutes. Yeah, but on physical hardware. With 25G network or 100G if you would like to have quite fast and beefy. Any more questions?
Okay, I can see one question in the chat. Can you give us examples of where MetalStack is already being used in production? Who was it originally developed for?
Yeah, thanks for the question. It is actually, it was developed originally for the German saving banks, and running there in production since 2018. So the internal Kubernetes cloud for the saving banks and related banks in Germany is running on top of MetalStack.io. We also have customers at the University of Innsbruck. University of Innsbruck is one of the customers which provide Kubernetes as a service for the universities in Austria. We also have one customer, it's in the power distribution area, so the underlying power network. This is critical infrastructure as well. Yeah, and our own MetalStack Cloud is based on that.
All right, thank you so much for answering that. Are there any other questions? Kurt is typing.
Yes, it's FITS. It's the data center of the saving banks. Have you tweaked the Kubernetes node or pod restrictions for the bare metal deployment? Yes, a bit. The max pods per node limit was raised to 500 in our case, which suits the bigger machines quite well, but could be modified during cluster creation by the end users also to lower it if you want to have more nodes or depending on the workloads.
I think there was also one interesting topic on our view on the Sonic stuff. What we think about it would be interesting to hear your view on it, actually.
Regarding Sonic, did I miss it? Yeah, we started with Cumulus for those interested, and still have quite a lot of workload based on the Cumulus operating system on the switches, but this operating system was acquired by NVIDIA and then closed and shut down. So yeah, this was bad, and we have to switch to Sonic, but yeah, now we are at Sonic. So if there are no more questions, thanks for having me. Thanks, Helena. I will stop sharing and give over to you back.
All right. Thank you very much for your talk. It was great, for your insights. I'm sure if there's any questions that are coming up later for you guys, or if there's anything that you do want to discuss and talk about, I guess you guys are always open for people to just reach out for you after the tech talk, if anything comes to mind later on. Yes, but as I said, thank you so much for your tech talk, and I'm going to share my screen again to talk about some community news and events in just a minute. All right. Yes, one of the biggest news that we have here at ALASCA is that we have a new employee, actually. So welcome to ALASCA, Daniel Gerber, who unfortunately can't be here right now, but he has started working for ALASCA this month. So he started on July 1st as a software engineer. And we are very happy to have him. He's working specifically for ALASCA Focus, the funding project, and he's going to help to make projects easier for users and developers on a day-to-day basis. And that includes everything from documentation to automation and tests, etc. So that's what he will be doing. We're very happy to have him on board. And I'm sure one of these next upcoming tech talks, he'll be here, and then if he wants, he can introduce himself to you, but I think many of you already know him. Right, moving on to the summit, which is our favorite topic. I'm sure everyone knows when it is. I think you probably have seen those dates a couple of times now, but you can never share them too many times. So November 3rd and 4th this year here in Dresden, you are all very warmly invited. We would love for you to attend our summit under the motto, Not from Alaska, from Europe, built for Europe's cloud future. And if you're wanting any more information on that, you can always go to the website or just ask us specifically. We are always happy to answer all your questions. A lot has happened actually this past month. Since our last tech talk, we have gone live with our program. So you can now see on our website all the talks that we're going to have, all the speakers that we're going to have at this year's summit. And we have also opened up our registration. So you can now register for your free ticket. Just like last year, it won't cost anything to attend the summit. We do ask you to please register though if you're planning on coming, because you will need a ticket to attend, just so that we can plan on the number of people that we're going to have at our summit. We also have an app. We had it last year, but this year we're planning on using it more, so you can also see the program and all the speakers and location and everything that belongs to it in that app that we're using. Right. So if you are looking for those links after the tech talk, we can always send them to you, or you'll find them on our website. You'll find them in our Matrix chat. I think you'll find them in our past LinkedIn posts. So, but if you are having trouble finding any of those links or information, please feel free to contact us at any time. Other news and events that are not Alaska specific would be the webinar from the Sovereign Cloud Stack, which is coming up on August 26th on SCS standards in practice. Praxis. So if you're wanting any more information on that, you can always go to the website. And there's also the link for registration here on our slideshow, which is also free to attend. And then we also have the SCS Summit coming up on September 24th. If I'm not mistaken, I think call for contribution is still open until August 1st. So feel free to turn in your contributions there too. And then we have the OSBA Connect 2025 coming up on November 13th. And that would be all news and events from our side. If you don't have anything, if anybody is thinking of anything else, please speak up.
Just confirming the deadline you've communicated, Helena. The CFP for
perfect.
SCS Summit runs out until the end of the month, or August 1st, I think is the precise date here.
Perfect. So as I said, if you have any topics that you want to turn in, you can do so. We as ALASCA will also be there as guests, of course, and we're looking forward to it. All right, then all that I have is a call for speakers for our Tech Talks for 2026, actually, which is still a while, but we're happy to report that we were able to fill all spots for this year, which is very great. Again, we want to thank you all for participating every month, for turning in your topics, for holding your presentations and your talks here. It's great. It's a great community, and we're very lucky to be in this community. And yeah, 2026 is still a while, but if you have topics already that you are thinking of that you want to turn in, you can already do so if you want to. And other than that, of course, we'll be uploading that tech talk to YouTube. We'll give you a short info when we've done that. And right, then there's just the very last point on the list, which is to save the date for our next Alaska Tech Talk, which will be on August 29th. And it will be with Uhuru Tech, with Max Hamati, who will be talking about UStack, which is a GitOps-based lifecycle management for OpenStack environments. And that would be everything from our side. I'm going to close my screen sharing so that I can see everyone again in case there's any other mentions or questions or anything. Which doesn't seem to be the case. So again, thank you so much to Stefan for your great presentation. Thanks to Gerrit for answering the questions in our chat. That's a great interaction. And it was great to have everyone. And if there's no further questions, I'm going to say bye.